a review. So first is cation conductivity. It's also better known as conductivity after a cation exchange. It removes any ammonia detection from the sample and converts our chlorides and sulfides to their acid form, which gives about a 10-fold increase, providing a more sensitive detection of these contaminants. Degas cation conductivity actually takes into account the carbon dioxide interference. It boils the sample that vents off the carbon dioxide, so you have more of a knowledge of what's really volatile anions versus how much is the carbon dioxide. Now, why do we monitor cation conductivity? Past experience, we know that these contaminants actually cause problems in our turbine blades. It causes corrosion fatigue. But not only that, cation conductivity, the main purpose is to monitor these chlorides and sulfate. So if we have better knowledge of what our concentrations are, then the plant can respond when we do get into what we call alarms. They can take measurements to maybe help prevent the metal surfaces in our system. And some of those other systems is actually in our boiler where we get chloride pitting. So now back to our scenario. With good trial results, I went ahead, received quotes for purchasing 4 new degas cation conductivity analyzers and provided them to the station. We talked about it with engineering to see where exactly we were going to place it, and we found out that once we removed our old equipment, it would be perfect for our new locations of the analyzers. Also, engineering said we didn't have to do many modifications to our sample lines or drain lines. Everyone was happy at this point. Unfortunately, and this is what we see quite often in our industry, we had budget cuts. So we had no funding to purchase these analyzers. So the management team, though, still interested in getting the status, said, well, is there something else we could use that would provide the same data? So I reached out to other vendors, as well as my other peers in the other regions in the Carolinas and Midwest, to see if they had any advice. Luckily, I talked with my corporate chemistry manager, and he suggested that I reach out to Martech. Talked with Martech, they did have an analyzer for us, and was actually within our reasonable budget. It was a fifth of the cost of what we were proposing to put in. So, station decided that we would go ahead and purchase the Martech Mark 24 degas cation conductivity analyzer. From now on, I'm just going to refer to it as Mark 24, since it has such a long name. So this analyzer measures specific conductivity, cation conductivity, degas cation conductivity, and for those that would use it, we didn't, it does provide a calculated pH. The Martech is calibrated to ASTM and NIST standards. It provides data on the display, but we can also send that data to what we call our DCS, or other recorders that we can trend the data from. The analyzer's ability to provide real-time data makes it pretty much ideal of an analytical tool for measuring stuff in high-purity substance, as well as condensate polishers and demineralizers. So we have specification for what we've used it for, conductivity. For specific conductivity, we had a range of 0 to 100 microsiemens per centimeter with a plus or minus 1 accuracy. Our cation conductivity was 0 to 10 range of microsiemens per centimeter with a plus or minus 0.1 accuracy. And then the final one, degas cation conductivity, has a range of 0 to 1 microsiemens per centimeter with a 0.01 plus or minus accuracy. Calculated pH for those that will use it ranges 0 to 14 with a plus or minus 0.1. And then the panel itself has a dimension of 14 by 26 by 6 inches. So how does it work? This is actually our unit that we have at Anclo. We basically have a sample line that feeds into the connection port of this analyzer. The sample flow is regulated with a flow meter, and it sends the sample through the first conductivity sensor, which measures the specific conductivity. From there, it goes into our cation resin column and is sent through the second conductivity sensor, which measures sent to the reboiler, where it's boiled close to a boiling temperature, where the carbon dioxide will vent off from the plastic tube and sent through the final conductivity sensor, which is our degas kind of conductivity. From there, it comes out the drain, and Anklook actually graded this drain. It's a little bit longer than what normally comes with the analyzer, so it could go directly into the sample sink. Now, it does provide a calculated pH measurement. Like I said, we did not use really that tool that much, but we decided we were curious and wanted to see how close it was with our inline, and it was plus or minus 0.05 with what our other analyzer was reading. So this is our current setup at Anklook. We have 6 grab samples. We have our condensate, our boiler feed, our economizer, boiler drum, main steam, and saturated steam sample lines. Currently, our non-degas kind of conductivity columns and probes are on our condensate and our steam. But with this, the Mark 24, we could connect it to any sample line. So that really helped us in troubleshooting throughout our water cycle system. Now, the only maintenance that this unit requires is changing out our resin. If it's purple, we know our resin is good. When it starts getting like the orange gold color, depending on how much iron is in your system, that's when you need to change out your resin. You're at the end of life. So the way Anklook used this instrument, they would connect it to a sample point, let it run for 20 minutes. This basically allowed the samples to boil up to our 95-degree Fahrenheit sample requirement. That would take off the carbon dioxide out of the system. Also, we wouldn't turn on the analyzer until we had flow and our columns were filled to protect the instrument. So, when have we used this unit? I have a few examples. The first one is, at low load, we have experienced high cation conductivity, and we've connected the unit and noticed that plus or minus 0.2 microsiemens, there's a difference. So that could, for us, it goes from an alarm to not. And that was due to the ammonia at low load. Ammonia is not a corrosive chemical when we talk about water in our steam cycle. Our next example is after our boiler blowdowns or the condensate overboard, we do experience high cation conductivity. This is because we're blowing down water, so now we have to make up. Our makeup water has high carbon dioxide, and that was our interference. And lastly, this one wasn't so much a troubleshooting, but more used as a verification to our other analyzers. After our water box cleanings, we noticed we have spikes of cation conductivity, and that's actually due to the contraction and expansion of our tube sheets in the condensate because of the temperature differences. And so there's small saltwater intrusions. Now, the reason I say this is for verification, we don't get sodium alarms. So all we get is a cation conductivity alarm, which for most of us doesn't make sense. If it's a salt leak, we would see both, but because it's so small, sometimes we think, oh, it must be an erroneous value, but it's not. They matched up to both instruments, so we use it as verification. Overall, the station is very pleased with this instrument. It has helped them many times with their chemistry excursions to figure out what exactly the data was telling them. We do plan on purchasing the other more inline degas cation conductivity in the future now that we have funding. But we will definitely use the Mark 24 for the other sample lines that don't have the analyzers. And I actually have other stations that have used this analyzer to verify their inline analyzers are reading correctly. Before I open up for questions, I do want to mention we have not used this analyzer for continuous monitoring. It's more so for troubleshooting, so we don't have any experience with OE on it. At this time, I'll address any questions.
Nope, go ahead.
Thank you for your time. Have a wonderful rest of your day.